video is going to talk about the top 10 secure coding practices. And if you go to the website for CERT, you'll find a list of these practices. And if you want your code to be secure, it's well worth adopting these secure coding practices. So let's take a closer look. Now, the first, as far as I'm concerned, is probably the most important, and that is that the vast majority of software vulnerabilities are caused by not properly validating input data. And so any data coming from an untrusted data source really needs to be verified before it's actually used. Now, interestingly, if we take a look at the MISRA C, they actually added an additional number of security guidelines for MISRA C 2012. And one of those guidelines was the Directive 4.14, which says the validity of values received from external sources should or shall be checked. Why is that important? Well, the C language has a lot of undefined behavior, and it's this undefined behavior that is the cause of software vulnerabilities. The next practice is to heed the compiler warnings. Now, a lot of people will compile code and just ignore warnings. Well, really, we should not just ignore the warnings. We should first of all modify the code to eliminate those warnings. And secondly, we should use the highest warning level. And then also, as can be seen here, we should use static and dynamic analysis tools in order to be able to detect and eliminate additional security flaws. We can't bolt on security, so it's very important to architect and design for security. And it's also very important to keep it simple, because the more complex the code is, well, the harder it is to maintain, understand, and test. And so ideally, we want to be able to measure a number of metrics on the code in order to get an idea of, well, how complex is that code? One of the metrics we might measure is the cyclomatic complexity. And possibly we might set a threshold for a particular value, and any function that has a higher value, well, it would probably make sense to refactor it in order to be able to make it less complex. Two more additional coding practices: default deny and also adhere to the principle of least privilege. Of course, this makes sense. Then also we should sanitize data sent to other systems. So important, if we've created some data, that we check the integrity of it before we pass it to some other subsystem. Practice defense in depth. Well, always best to have a number of layers of defense, so that one layer is not adequate, then hopefully there'll be another layer of defense that can prevent that software or that security flaw from becoming a vulnerability. And then we should also put in place effective quality assurance techniques, things like penetration testing, source code audits, but also fuzz testing. And fuzz testing is basically where we're going to take a particular function and we're going to try invoking it with a range of different inputs, a lot of which may be invalid, checking that the code is robust and doesn't crash. And then finally, we want to adopt a secure coding standard. And there are two coding standards which are well worth bearing in mind. First of all, we have the CERT C coding standard. But if you're working on embedded software and you want your system to be safe and secure, then it's highly recommended to use the MISRA C standard, especially with these additional security guidelines. Then there are additional two bonus secure coding practices. First of all, we need to think about what threats could possibly occur, and we should model these. And having modeled them, we can then define some security requirements to ensure that our system is able to handle all those threats.